On October 4, 2021, Facebook went offline. Not a region, not a service. The entire company, Facebook, Instagram, WhatsApp, Messenger, and the internal tools Facebook employees use to diagnose and fix outages, all of it, simultaneously, for 6 hours. The cause was a misconfigured BGP update that withdrew the routes advertising Facebook's IP addresses to the global internet. Every router in the world that handled internet traffic stopped knowing how to reach Facebook. The company didn't disappear. Its servers were running, its data was intact, its internal network was functioning. But from the perspective of the global routing fabric, Facebook had ceased to exist. And here is the thing worth sitting with about that incident. Facebook is one of the most sophisticated infrastructure organizations on the planet. They run their own physical data centers, they design their own hardware, they operate their own global backbone, they employ some of the best network engineers in the world. They had redundancy, diversity, failover, and isolation at every layer they controlled. None of it mattered, because the failure was in a layer nobody controls. Every isolation mechanism has a limit. Most limits are engineering problems, things that better design, more configuration, or a larger budget can address. But some limits are not engineering problems. They are properties of the infrastructure the entire industry shares and nobody owns. Understanding where those limits are is the difference between designing for resilience and designing under an illusion. Think about a ship at sea. A well-engineered ship has watertight compartments. If one section floods, the others stay dry. It has redundant engines, multiple navigation systems, backup power, emergency protocols. The internal isolation mechanisms are sophisticated and well-tested. The crew knows exactly what to do when something inside the ship goes wrong, but the ship is still at sea. And the ocean has storms that no compartment design addresses. It has rogue waves that exceed the parameters any structural engineer planned for. It has currents, reefs, and fog. The ship's internal isolation ends at the hull. The ocean begins there. Cloud infrastructure has a hull too. Below a certain layer, the isolation mechanisms that engineers design, configure, and monitor simply do not reach. What lies beyond that layer isn't controlled by your provider, or by you, or by anyone. It's the shared substrate the entire internet sits on, with properties that were set long before cloud computing existed and will remain after it evolves into whatever comes next. There are 3 of these limits that every cloud architect needs to understand, not to despair about them, but to design honestly within them. The internet routes traffic through a protocol called BGP, Border Gateway Protocol. It's the system by which every autonomous network on the internet, every ISP, every cloud provider, every large organization advertises which IP addresses it's responsible for and learns how to reach everyone else's. BGP is not owned by anyone. It has no central authority. It is a distributed protocol built on trust, specifically on the assumption that every network on the internet will advertise only the routes it legitimately controls and will not claim to be the path to addresses it doesn't own. That assumption is routinely violated, deliberately and accidentally. BGP route leaks happen when a network accidentally advertises routes it shouldn't, pulling traffic toward itself that was meant for someone else. In 2010, a Chinese ISP briefly advertised routes for a significant portion of the global internet, causing traffic from the US and Europe to transit through China. In 2019, a small ISP in Pennsylvania accidentally announced that it was the best path to large portions of AWS, Cloudflare, and other major providers, pulling traffic through a network it had no capacity to handle. BGP hijacking is the deliberate version. An attacker claims to be the legitimate path for a set of IP addresses, intercepts the traffic destined for them, and can decrypt, modify, or simply drop it. AWS, Azure, and Google cannot fully protect you from this. They can sign their route advertisements using RPKI, Resource Public Key Infrastructure, which allows routers to validate that a route announcement is legitimate. But RPKI adoption is incomplete. Not all networks validate. Not all networks sign. The global routing fabric is a shared resource with incomplete governance, and its failure modes affect every workload running on every cloud provider simultaneously. As Facebook's engineers discovered, your isolation architecture ends at your provider's network boundary. The BGP layer that connects that boundary to the rest of the internet is shared, uncontrolled. and capable of making your infrastructure unreachable regardless of how perfectly everything inside it is designed. Cloud providers invest enormous effort in making their infrastructure look geography independent. Multiple availability zones, multiple regions, global load balancing. The premise is that your workload is not tied to any single physical location, and therefore not vulnerable to any single physical event. This is substantially true, and it has a hard limit. Data centers consume power. The power comes from the grid. The grid is physical infrastructure with physical routing, cables, substations, transformers, that share geography with everything else in that area. A natural disaster that damages the physical grid in a region affects every data center in that region, regardless of which provider operates them, or how many redundant power feeds the data center has. When the feeds from the grid go down, the generators run. When the generators run out of fuel and the delivery trucks can't get through, the data centers go dark. Fiber routes are the same. The internet's physical backbone follows physical paths. The transoceanic cables, the terrestrial fiber runs that connect data centers to each other and to the internet, those paths share geography. The 2011 earthquake and tsunami in Japan damaged multiple submarine cables simultaneously. The 2022 Tonga volcanic eruption severed the country's only submarine cable connection to the internet for 5 weeks. This isn't an argument against multi-region design. Multi-region is the right answer to most availability problems, and it works well for most threat scenarios. The limit is that when the physical substrate is compromised at a geographic scale, the logical architecture sitting on top of it cannot compensate. A multi-region deployment across US East 1 and US East 2 has 2 regions and 1 electrical grid. The isolation architecture that spans regions assumes the regions are independently failing. That assumption holds for most failure modes. For correlated physical failures, events that affect the physical geography those regions share, it doesn't. Designing honestly within this limit means knowing which physical dependencies your independent regions actually share, and deciding deliberately whether workloads that require absolute resilience need to span genuinely geographically disjoint infrastructure, different seismic zones, different power grids, different transoceanic cable connections. Most workloads don't need that level of design, but the engineers who make that determination consciously are making a different kind of decision than the ones who assume multi-region means independent. The third limit is the most fundamental and the least discussed. Every isolation mechanism in your cloud environment is enforced by software that your provider operates and that you cannot inspect. You cannot read the hypervisor source code. You cannot independently verify that the isolation boundaries it enforces are implemented correctly. You cannot audit the physical access controls at the data centers where your infrastructure runs. You cannot confirm that the provider's employees with elevated access cannot read your data. You can read the documentation, the compliance certifications, the audit reports, but you cannot verify the thing those documents are describing. You can only trust it. This is not a flaw in cloud computing, it is the nature of a shared service. You receive leverage, the ability to operate infrastructure at a scale you couldn't build yourself, in exchange for a degree of trust in the operator of the layers below you. That trade is worth making for almost every workload, but it is a trust relationship, not a verified one. What this means in practice is that the root of your isolation architecture is a party whose behavior you are trusting, but cannot audit in real time. When AWS says your hypervisor isolates your virtual machines from other tenants, you are accepting that claim on the basis of their reputation, their compliance certifications, and the absence of evidence to the contrary. For the vast majority of workloads, this trust is well placed and well maintained, but it is the limit, the hard boundary below which your isolation architecture does not reach, the controls you can configure, the boundaries you can verify, the scope you can map. All of it exists above this layer, below it is trust. The engineers who understand this don't distrust their providers. They just know exactly where their verification ends and their trust begins. They know which controls they can confirm and which ones they can only assume, and they can design accordingly. 3 limits. BGP, the routing fabric nobody owns. Physical geography, the substrate that logical architecture sits on and cannot replace. Provider trust, the foundational layer you depend on but cannot verify. These are not problems to solve. They are properties of the environment to understand. The engineers who have absorbed this aren't pessimists. They're not arguing that cloud infrastructure is unreliable or that isolation is meaningless. They're arguing for something more precise, that every isolation architecture has a boundary at which it ends and something else begins, and that knowing exactly where that boundary is allows you to design with honesty, rather than with the false confidence of someone who hasn't looked past the layers they control. Facebook had world-class engineers and world-class infrastructure. The BGP update was a mistake that any team could make, but the reason that mistake could take down the entire company, including the tools needed to fix it, was that the boundary between what was isolated and what wasn't had never been fully examined. The hull was well designed, nobody had mapped the ocean. The limit of isolation isn't a warning about what might go wrong, it's a description of where your architecture ends. After that, it's the ocean, and the ocean doesn't have a configuration file.